Okay, students, basically today we are going to implement the lab 2, which is about the image cleaning and preparation for the deep learning models. Basically, why we need pre-processing when any training of the model or while developing any system. The important thing is that data we have in the raw format, like we have captured some images. The issue with the images can be the different means the channels means either one can be in a grayscale, another one can be in the RGBA and different channels. Okay, the other thing, second thing, we can say that they have different sizes. Like one of the image maybe 1200 by 1200, another is 600 by 12, and some other image in different sizes. So basically, in this scenario, it will be very difficult for the neural networks to basically train the model. That's why we need to bring them in a constant or the unique shape, or the standard shape. Like all the images should be in, let's say, 34 by 34. In this scenario we are considering 35 4 by 34. So it can be any size depending on the problem you are solving. Let's say uh, your problem can be solved with the 36 by 36 bit. You can consider that one. Okay, it totally depends on the type of problem we are solving. So basically, while deciding these things, it should be not too small. Means was selecting very small window that is not capable of capturing the whole features of an image, or it can be too large. So in case of the large also we cannot achieve the objective. So it should be optimal, means the size which is suitable for the training of the algorithm as well, and also captures most important features. Okay, so for this lab, basically, you will be learning about the channel standardization and resizing, embedding, and normalizing the image for the lab 2 part. Okay, first thing, channel standardization is basically the process I have discussed. Like one of the images in grayscale, another one is RGB, another one is RGBA. For this example, we will be converting all the images into the RGB standard, means whatever the input image was, convert into RGB to make it standard and easy for the algorithm to basically learn the similar kind of features from the image. Okay, for this one, basically in the part 2, I have used a random image. If we go down here, for this one I have considered a random image, but you have to make changes into the function to basically display or apply this channel standardization on the original image, which is sample.png. Right. Okay, for this one basically you have to make changes, small changes in the function, and input the sample image path. Because if we go down, sample image path is basically the original image. Okay, so we have to basically input this one directly to the second function. Okay, okay, so next one is basically resizing and padding. So this step is important to basically bring all the images into the fixed dimension for the CNN to extract the important features and learn on that. And this will basically reduce the computation cost as well, and also training time will be reduced. Like let's say if we were considering the original image, which was 1200 by 1200, and all images are 1200 by 1200, and the color pixels out there means all the images are colored, then that might take let's say 1 month to train the model. But if we reduce it, it will take less time, like in 1 hour 2 hour we can train the model. It depends, totally depends on the algorithm itself and also on the training data set. Okay, so for this one basically you have to experiment with the target size we have declared as a global variable, so you can change the target size from there. Okay, you have to try different sizes like 64, 128, 256. Okay, and observe what is basically the difference in the pixels, what is difference in the image, is there any effect, or are we going to lose any important features. So you have to experiment it. Okay, then task 4 is basically the normalization and reshape. Okay, so if we consider the original image, it has pixel values, or the matrix of the image seems to be in the values which are range from 0 to 255. Okay, so every color combination we can represent from 0 to 255 scale, right? Zero is basically the dark black, and pure white is the 255 pixel. Okay, so based on the variation of these values we can form different colors and color combinations. Basically the standard one we are following is the RGB. Okay, so basically mixing up these colors we can make different colors. So every pixel has a values from 0 to 255. Okay, so normalization is basically helpful to basically bring this 0 to 255 scale to another scale, which is easy for the algorithm to basically train. And like in this scenario we are considering the ranges from 0 to maximum 1. Okay, so after normalization all the values will be rescaled to the new matrix, which will only contain the values between 0 and 1. Okay, okay, for this example we are basically considering the 4D tensor shape of the input, which will be means the output of this lab will be base size, which will be 32, let's suppose, and height and width, that one is selected by the target size. So in this scenario we are considering 30 by 34 by 34. So size, height and width will be 34 by 34, and channels for this one we are considering the RGB, means three channels. Okay, so we are expecting this output from this one. Okay, for the further exploration basically you have to do is perform the batch processing instead of the one image. You have to perform this on multiple images. Like in a real scenario we don't have only one images, like we have multiple images, so we have to basically process all of the images at once, and then calculate the features for the model training, and then divide based on the train test split. Okay, next one what you have to do is try the different padding colors, change the padding colors in the resize and pad demo function. You can basically do, let me scroll down. Yeah, from here you can basically change the color of the padding. Okay, so you have to experiment with this one. And if we go down, last one is research and try implement an other resizing method available in the Flow library. So this one task you will be doing. Okay, so like for the all labs, first step is to basically mount the Google Drive to basically import the images from the folder. Okay, So let's say if you have multiple images, then you have to change this folder to the one folder you have in your library. Like in my case, this is simple.png, so you can change it if let's say you are processing the multiple images. So all the images available in this folder, like in my case I have a deep learning lab folder, so all images in this folder will be extracted here. Okay, so let's say I have image in lab02 file, right? So I have to change this one to lab02 sample. Let's see if it runs or not. So first step is basically here we are using different libraries, like importing OS is basically helpful for communicating with the OS. Then path library deal with the paths, like here we are extracting the path from the OneDrive. And NP, as you know, is NumPy is for computation, and this one PIL is for the images, like we are dealing with the images. And last matplot library is used for the plots. Okay, let's run this one. Okay, there will be prompt to connect with the OneDrive, so you have to simply connect with the OneDrive. Okay, accept, continue. Okay. Okay, so here you can see that message that Google Drive mount is successful. How you can verify? Just click on the files and my drive, again my drive, then again my drive. And in my case, I'm saving the files in deep learning library, so library 2. Okay, so for this one, basically you have to update the path of this sample image in your scenario. Like you have to provide the path of the folder you are using. Okay, here and also here. So in my scenario, I'm using path. How to do? You just simply have to copy the path and update here. Okay. Let's say in my scenario, I'm updating it. Okay. Okay. Then again, you can run it. Next step is this one is basically the function which displays the original image. The one uh, we have used here is basically the sample.png image. Okay, why displaying the information is necessary? Because sometimes we need to observe that either the data is correctly loaded or not. What is the format of the data? So this is basically before feeding the data to the model, we need to verify the data is correct or not, what is the original shape. We want to learn about the data so that we can apply the further pre-processing steps. Okay, so here basically we are using different functions like exist basically checks that either the image is available or not, and sample path is basically the input here, which will be forwarded as a sample.path, which is basically the path of the original image sample. If we go up here, you can see this is basically the path of the image. Okay, so we are forwarding the path to the function which is used for displaying the original image. Okay, so first is basically checking either path is correct or not. If correct, then image, save the image into the img. Img is a variable, so image.open, this will basically helpful to open the images from the path will be this one. Okay, and finally just we are using the plt, the one we have declared here at the top. Plt, this one is basically we are assigning, we can say that this we can say that this is a synonym, okay, of this one. So we are assigning this as a PLT, means PLT is the name. So first one is basically the figure size. You can change this one from 4 to 8, whatever. This is basically the square, means 4 by 4 image. And IM show is used to display the image. So here we are inputting the IMG, which is a variable contains the original image, and plot title is basically helpful when we want to display a title at the top of the image. Like sometimes it's helpful to really tell the audience that the graph belongs to the accuracy or something, so that's why title is important. Okay, here axis you can keep it on or off. This will basically be x axis and y axis. Okay, so in the title basically we are displaying the image size, means height and width, and we are directly getting using the size function. Size is a function helpful to basically capture the automatic size of the image. So here we are considering 0 index and 1 index, means at 0 index the height of image is saved, and at 1 index we have the size of the width. Okay, print is basically it function is used for the display message. Okay, like here. So the message will be displayed, the image loaded successfully with the size, and mode will be either it's a RGB or it's a RGBA, whatever original. So original image in this scenario is RGBA, right? If let's say the image is not successfully displayed, then the exception error will appear. Let's run it. Okay, so here we can see the information about the image. So this one is basically the title. If we go up here, the text which is going to be displayed is the image, original image, and then the size, which is basically automatically getting from the image. Okay, you can replace it if you don't want to show the size, but here our aim to learn about the original size of the image, that's why we have used this one. Okay, and for this one basically we are printing the information. This one, image loaded successfully, size is this one, and mode is the RGBA. So you can basically play around with this one as well, if based on the requirements. Okay, okay. So next function is basically used to display the original image and then convert it mode, means into RGB. Let's say in this scenario we have a image in RGBA, so that will be converted into the RGB. But for this one we are considering the demo image, which you have to change it. Let's say I'm running it. So original was mod L, means one channel only, and here it is converted into the RGB, right? So let's modify this function to basically display our image. Here we will be using sample path. Let's let me yes. Here we will be using a sample path, and again for checking the image we will be using try and catch block. So just copy this try and catch block and paste it. here. So what this code is basically doing is checking either image is correct or is there any error with the image or not, and then if not, try to load the image, which is image dot open sample path, and print image mode original and get bench means channels, and try to fix like the convert to RGB. So if image mode is RGB, if color convert into the RGB, print converted color image. Okay, so after convert is basically the function which basically converts from one format to the another. Else image color, if it's already in the RGB, just show images already in the RGB mode. Okay, so after, let me comment this one because we don't need this one. And okay, so for the display, basically we don't need this one as well. So just comment. Basically, the commenting is the best practice whenever you need the same statement. Let's say later on you have done a mistake and you want to revert back. So comment is best approach. Basically, don't comment everything, but the important thing. Let's say sometimes you need it, so you can basically revert back. So here we have not in the image gray. We have the original image in img variable. So this will be img. Okay, and next one is we have image color. Okay, so i think I think we are all set. Yeah, just provide the input image to the function, call the function and provide the input image. So after this, hopefully it runs well. Yes. Okay, so basically we can see that the original mode of the image and then converted mode into the RGB, right? Okay, here original mode was basically the RGBA4 channel and it has converted into the RGB, right? If I'm not mistaken, we have error here. This should be automatically getting from the image, it, instead of just displaying the text. Okay, so this will basically get automatically image mode from the image. Okay, also for the second title as well, make it automated, like instead of getting from the just displaying, we are getting from the image variable basically. Okay, let's run it. Yes, now is you can see that original image was in RGB and was a had 4 channels, right? And after processing, we have 3 channels. 3 channels are basically the dimensions, like color combinations, and it's sometimes helpful to basically reduce it, like to reduce the complexity of the algorithm. Sometimes might be very difficult to basically process that huge number of pixels and channels. So we have to make it very simple. Like for the reason is that the algorithms are not capable enough as our minds are. We can identify the things, but for algorithms, it's very difficult. Okay, so we are done with the second task, which was basically converting from uh, this one instead of Instead of using the random image, we have just changed it successfully. Okay, there is issue with this notebook, like this should be step task 1. Yes, this is basically the task 1, and this is task 2, 3, and 4. Okay. Okay, so we are done with task 2. Let's move to the third one. In third one, basically we are reducing the size of the image from the original to the 34 by 34, the one target size. Okay, and also we are applying the padding. Padding is useful when we want to retain the original features of the image, and without basically disturbing its original shape. We need a padding. Padding is basically adding the layer of zeros at the means the borders of the images. It will basically add a layer of zeros, black lines, to preserve the original features of the image. Okay, so let's run this one and see. Again, we are using try and catch statement first. Okay, so in this function, basically you can play around with this one, RGB, convert to RGB. If it is image is not in RGB, again we are basically rechecking the mode of the image. And okay, these are basically we are declaring some variables, then calculate the scale factor, which will basically rescale the image to the different format based on a minimum and initialization integer and these things. So basically rescaling from original size to the new size. Okay, you can play around with this one as well. Okay, like instead of automatically fixing the size, you can play around to change the size predefined using a variable. Okay, okay, for the padding, basically we are using left and top, two sides. Okay, you can basically change it and try to apply on the other sides and see what happens, right? And finally we are displaying the original image and targeted image. Okay, this one is a width, this one is a height, basically the original width and height, and the target means the after conversion, right? So this plague line basically shows a padding. You can play around with this one. Let's say we want to change these values to 255, 255, 255. Let's run it. Basically the padding color should change, and let's say we want to make it 25. See, the color has changed really. Okay, so let's bring back to 0, because 0 is very easy to handle, right? And yeah, let's try with the left top and bottom and right as well. Bottom and right as well. See what is the effect. Is there any effect or not? Top, and we have bottom, and we have right. No, this one is not applicable. So okay, just leave it. You can. Okay, here we have error. We have to remove it back. Okay, so this will basically shows the original and padded image, right? Let's move to the last step, which is basically the normalization. Okay, normalization is basically helpful when we have an image in, let's say, original shape is to from 0 to 256 or 255, means every image has a pixel ranges from 0 to 255, so we need to basically mm, convert it into the format which is basically in the ranges of zeros and ones. Okay, so in this function also you can, instead of declaring the raw images using the random function, you can change it basically to the original image and also the scale pixels for, but for this one we are considering the demo. Okay, so we have two types of the pixels: raw means original, and scale means the one which have been converted into the scale of 0 and 1 from the original 256 to, let's run it. Okay, so basically this will be the output. You, if let's say you want to check how the raw and original pixels look like, you can simply print, okay, raw pixels and as well as scale pixels to see the difference. So if you go down, these are basically in the ranges of 0 to 1, means after conversion, and these were basically the original pixels inside a image in the range of 236 256 and these things, and after conversion it will look like this one. So very easy for the algorithm to basically handle this one. Okay, okay, so here basically instead of considering the raw image, you can basically change it to the image we were considering previously. Let's try this one if it works or not. Let's say, we are considering this one, making some changes into the function here, and okay, this will be the sample image path here, and then we need to Try this one. Try and catch statement basically. Okay, so image is in the image. Let's make this one as a, instead of raw pixels, we will be considering this. Let's copy this one and make it as a comment. Make changes into this one. Instead of the raw pixels, consider img, and here as well img. Let's see if it works or not. So scale images, final shape is, hopefully there is no error. And let's try this one if it works or not. There is error, unsupported image and float. Try for image means we have some issue. Let's explain the error. Okay, I think raw image values, convert image to numpy. Yes, before basically we need to convert it into the numpy array before running it. Okay, so this will be basically the shape of this image. Originally we had values from between 255, and after conversion into the 1. So basically you can try this one. At the end of this lab we have a tensor of 32, which is basically batch size, which you can change. And then height of the image is 34, and width also 34, and channels are 3. Okay, yes, here we just converted the image into the image array, right? So few changes. And basically, let's say if you want different page size, you can basically change it from here. Like, let's say you want to select 5 as a page size. Let's try, is it running or not? Hopefully yes. Here we have a page size of 5. So basically you have to experiment with this one. Hopefully it will be very helpful for you to learn. Again, for the conclusion, let me conclude. Basically, whenever we have a data in the raw format, like we have collected from the different sources, we have to basically pre-process it to convert it to make it as a standard data set of same size. Like if we have images, it should be in the same size. Like here we are considering 34 by 34, then we need to convert it into convert the mode. Like if it is in the RGBA, all images should be in one format. You can consider the RGBA for all. It's up to the problem which we are solving. For this one, for the demo, we are using RGB. Next one is basically the padding and rescaling basically. So whenever we have a large image, we cannot crop it. We basically have to resize it. So for resizing, we are using some mathematical functions and then resizing it and also preserving the original features of the image instead of disturbing them. And the last thing is we are applying the padding of the zero, means adding the zeros at the borders of the image to basically preserve the original shape of the image, okay, without losing any important features. Hopefully this has clarified the purpose of this lab. Okay, so see you in the next lab.